Welcome to Chapter 18 notes from Compass that I'm going to just do a quick overview of. So Chapter 18, we're looking at right angle triangles to start with. So using trigonometry principles of SOHCAHTOA to find out whether we need to find opposite, hypotenuse, the angle or the adjacent in a form of a question. Please draw the diagram out, label those sides, and then you know how to manipulate the equation to find your answer. For example, if unknown is on the top, we can multiply the bottom across. If our unknown's on the bottom, we can swap these two things to find our unknown. Once again, if you have enough information, you can use c squared equals a squared plus b squared. You can use that to even find information, so you can find angles, etc. Alright, when we don't have a right angle triangle, we've got a couple of rules we can use. So, as I said, we need to go through and do a quick test to check the information we have. Is it a right angle triangle? If it is, then we can use, say, SOHCAHTOA, or we can use c squared equals a squared plus b squared. If we have a pair of information, which I'll go through in a second, we can use sign rule. So choosing which two of these you want to add together. And then if we've got the correct information, so we've got, say, the angle and we've got two sides, we can use cosine rule. So for example, one of the cosine rules would be a squared is b squared plus c squared minus 2 times a times b times cos the angle we are looking for. Know when to use these. So as I said, right angle, you can use those. If we have a pair of information, we use sine rule. If we've got the right information or we don't have a pair, most likely it would be cosine rule. Also, finding that third angle in a triangle. If we've got enough information, find that third angle, and then generally it will help you be able to use one of these formulas. Alright, so sine rule, label no matter what the question says, make sure you label them A, B and C. This will help you then easily use the correct rule instead of trying to work out what F is in the rule if F is labelled on the triangle. When we're using two sine rules, when using sine rule, there potentially can be two solutions to an angle. There's our formula there. So the angle you've got, just do 180 minus your angle. I've got the notes on Compass for that, so please go to Compass and have a look at my worked notes for when to use if there's two solutions to an angle. Cosine rule, we've got our cosine rule, and then what I've done for you here is manipulated all these formulas for you. Do not forget to take this square over and square root your answer. That would be an easily forgettable thing under stress of exam or SAC. Do not forget that. If you can remember just one of these, and for example, if you're trying to find B, A and C must be here, and you're using the B angle. If you're trying to find C, A and B must be here, and using the C angle. Then rearrange this to find the angle. So don't forget to inverse cos the answer. So cos minus 1. Once again, way you can remember it, if you're trying to find A, you subtract the A. If you're trying to find the B, you subtract the B. C, subtract the C. The other two values, A, B, or C, you have them together on both the top. You plus them together and then you multiply them on the bottom. Little things like that can save you a lot of time. Instead of spending 1 or 2 minutes trying to find the formula in your resource booklet. There is a video on Compass of when to use cosine or sine, but as I said early on in this video, go through those steps. Is it a right angle? Do I have a pair? If not, then cosine. Also finding out that third angle. Area of a triangle. So basic formula for area of a triangle, if we've, for example, got just a triangle, we have a base and then we have a height. So it's just half times the base times the height. If you've been given an angle, there's the area is half times BC times sine A. Easiest way to remember that instead of having the formula is that it's half times the two sides that make the angle. Okay, so half times B times C and then sine A. So if you've got any question, you've got the angle and you've got the two sides that make the angle, you can work out the area. Heron's formula. Use this one when you do not have any angles. So you've got all three sides. First off, you need to find the value of S, add all your three sides up, divide by 2, and then substitute in the S into this formula. A way to save time is if you've just got your standard scientific calculator, work out ands, the answer, and then use ands in all the values for S's. Instead of typing in the value, you can do square root of ands, bracket ands minus the value for A, ands minus the value for B. That will save you 20 seconds, which might be enough time at the end to get that last question finished. Angle of elevation and depression. This goes back to using parallel lines. Okay, so we've looked at this, been able to identify that this angle is the same as that angle there, and this angle also equal 180. So be very careful if in a question you've been given get rid of this. If you've been given parallel lines, understand the properties that are available. So they will, sorry about these not being so straight. Parallel lines, they should be denoted by using those arrows. Understanding the properties. So even if we've got lines going around everywhere, this value here is the same value as this all the way around. And the same as this one here is the same value as that there. If we've been given isosceles triangles, understand that those values are the same. Use the principles that are given in parallel lines to help solve questions. The same works as if we go and have right angle triangles in here. You can calculate information really easily just by using the information from parallel lines. So angle of elevation equals angle of depression. This is very, very, very important when we go on to talking about bearings. So for example, if we had ourselves information here, we go up there on an angle of 40 degrees, and then we move on. The question might send us off that way for 30 degrees. Okay, you can work out angles by using elevation and depression. So if this is 40, that in there must be 40. They've given us that there is 30, so we can calculate that angle is 70. We can do the same if that's 30 there. We can draw ourselves a compass. That there must be 30. So then in here, for example, it would be 60. And then you can go around and you can work out a heap of information by using angles of elevation and depression on compass bearings. One bit of information for bearings, if we say have a compass and we go on 30 degrees and then we come across a bit and then we come straight back, that angle in here, so I'll highlight that in red, this angle in here is no longer 30. Be very careful. The angle from north around to where we were, the bearing of there is 30, but because we've come across and we've come back, do not use that as 30. We can then calculate that angle using relevant information, using sine rule, cosine rule, find pairs, find angles with sides. We can work out that angle in there by using the relevant information. Alright, and 3D problems. A couple of things to remember 3D problems. Generally look for right angle triangles. So there may be questions that might involve cubes or prisms or etc. like that. Alright, here's a 3D shape, really rough and quick. Example from there to there, if we draw that in, that's a right angle triangle. They might give you these lengths here on the sides. It might ask for the distance across there, so we can come back and have that as a right angle triangle. You can use Pythagoras to find that diagonal on the base. You might be given the value of the vertical. You can then use SOHCAHTOA to work out angles of elevation, depression, etc. So first off, check that you can use all the formulas that are related to right angle triangles. If not right angle, then use sine or cosine rules. So just first off, double check that you can use the information for a right angle triangle. Draw cross sections of shapes to help you understand which formula to use. So in case, for example, this shape, you might need to work out the diagonal on the base. Draw it out again, and then you can then see that it's a right angle, and then use your opposite adjacent hypotenuse. So redraw the picture out. So it gets a little bit confusing when we put all the information on the one picture, on the one diagram. Draw out the information. And on Compass, I've got work solutions for questions 6, 8, 9, and 12 for this chapter. These ones are really hard. One of them is about a plane flying over some land. Really poorly written, really poorly described. Don't stress if you can't understand that. Have a look at my work solutions that I've got up there and see if you can understand that. Any questions, you can come see me, send me any emails that you want to, and good luck with revising for the Chapter 18 notes. Thank you.